Example 7, the number of two different letter arrangements there are of the letters of the word match. Match has 5 letters and we are interested in 2 letter arrangements. So we will draw 2 boxes because we are interested in 2 letter arrangements. And the 2 letters need to be different. So we can't repeat the letters. For the first box, we have a choice of 5 because the word match has 5 letters. And once we've chosen one letter, for the second box, we only have a choice of 4. We are not allowed to repeat the letters. Hence, we have a choice of 4 letters for the second box. And the number of permutations is the product of these two numbers, which is equal to 20. Let's look at example 8. The number of 2 letter arrangements there are of the letters of the word match. Now this example, example 8, is different to the previous example, example 7, in that example 7 has a restriction. The letters, the 2 letters ought to be different in example 7. There is no such restriction in example 8. Since we are after 2 letter arrangements, we still draw the 2 boxes. There are no restrictions, so we are allowed to repeat the letters. The letters need not be the same. The letters need not be different. So for the first box, we have a choice of 5 letters. The letters can be repeated. Hence, for the second box, we have a choice of 5 as well. So the number of permutations is the product of these two numbers, which is 25. Let's look at example 9. The number of ways of arranging the letters of the word match. So in this example, we're looking at arranging all the 5 letters. Hence, we need to draw 5 boxes. And the number of choices for the first box, we have 5 letters, so we have 5 choices for the first box. After we've chosen one letter, we only have 4 choices for the following box, and then 3 choices for the one after that, 2 choices for the one after that, and 1 choice for the last box. So the total number of arrangements is 5 factorial. So in general, if we have a word with n letters and we are arranging all the letters in that word, the number of permutations is given by n factorial. And n in this example is 5. Example 10, the number of 3 different digit arrangements there are of the set of digits 0 to 9. So in total, we have 10 digits in this set, and we are after 3 digit arrangements. And these 3 digits ought to be different. When forming a 3 digit number, the most significant digit cannot be 0. In other words, 0 followed by any 2 digits, for instance 2, 5. This is not a 3 digit number because the most significant digit is 0. The most significant digit in a 3 digit number cannot be 0. So we keep that in mind in forming the 3 digit numbers. Since we want to form a 3 digit number, we will draw 3 boxes. This being the most significant digit and this being the least significant digit. For the most significant digit, we can't choose 0, so we only have a choice of 9 digits. So we have 9 choices for this box. For the second box, once we've chosen a digit into the first box, we are left with 9 digits. So for the second box, we have 9 choices. And for the third box, once we've chosen 2 digits, we're left with 8 choices. So the number of permutations is 9 squared times 8. Example 11, the number of 3-digit arrangements there are of the set of digits 0 to 9. Again, the most significant digit can be 0. Notice the difference between this example and the previous example, example 10. We were not allowed to repeat the digits had to be different. In this example, there is no such restriction. So we are interested in 3-digit numbers, so we'll draw 3 boxes. For the first box, which is the most significant digit of the 3-digit number, we can't choose 0 for this box, so the number of choices for the first box is 9, since we can't choose 0. Now once we've chosen that, for the second box, now we are allowed to repeat the digits, so we can choose any one of the 10 digits for this box, so we have a choice of 10. Same with this, we are allowed to repeat the digits, so we have a choice of 10 for the third box. So the number of permutations is just 9 times 10 squared. The number of 3-letter, example 12, the number of 3-letter codes there are of the letters of the alphabet, given the letters cannot be repeated. So here we are after 3-letter codes, so let's draw 3 boxes. And the letters are not allowed to be repeated. So for the first box we have 26 choices, and once we've chosen a letter, for the second box we have 25 choices, and for the last box we have 24 choices, because we are not allowed to repeat the letters. So the number of permutations is 26 times 25 times 24, which can be evaluated using a calculator.